This is a video demonstration for our first lab in this course. I'm going to be pointing out some of the hardware, how to wire it up, and then we're going to be working with some of the software here over on the workstation on the computer, Studio 5000. So to familiarize ourselves with the workstation here, the lab station, our PLC hardware, everything, this is our PLC up here. We've got an external power supply for our inputs and outputs. And over here we have a network switch, and this network switch allows a few different things to communicate. And then over here on the far right, this is some hardware that we're not using in the course. It's part of the lab, but we're not using it. It's part of our DCS for another course. Down here on the table, we've got a little trainer board here with some switches and LEDs that we're going to be demonstrating here as well. So let's have a look here at this network switch here just to kind of show how things are connected. You can see this blue cable, this Ethernet cable, runs down and over to this card right here on our PLC. And then also there's a yellow cable here that's connecting up to that switch as well. And what that allows, this switch allows, is for these two devices to talk. And then up here off the top, there's a red cable going off the top, and then there's this lighter blue cable coming down and going over into that panduit right there. The lighter blue cable goes over to our HMI here that we won't be using in this course. It gets used later on in the program. But the one that we will be using here is this red cable, and it goes up over the back, and then you can see it flow. It's coming down right here, and then it goes into the back of our computer down here. And so this allows our computer to communicate through the switch up here, the network switch, out to our PLC. And so the way that our PLC is set up here, we have our power supply here for all of the modules. Right here, there's an on-off switch you can see right here that turns it on and off. And then also this here is where our AC voltage, 120 volt AC, connects to the power supply. And then the power supply then takes it. You can see there's the input there, and then it outputs a few different voltages. You can see a 5 volt, 24 volt, 3.3 volt, and 1.2 volt voltage, depending on what the modules require for power. So that's what this power supply is doing. Furthest left, typically on all PLCs, you'll usually see it over here on the left side. And now going from left to right, I'll point out the modules we have here. We've got, just so you can see the part numbers here, 1756-L81E. And we can basically ignore anything after the slash there on our part numbers. I've put the part numbers here out front here with a sticker. They're usually, you have to pull the module out, and they're on the side as well. Modules are fairly easy to pull out. There's just a tab here, and you just pull it out. I've actually got another video where I do that, but I'm not going to do that today. Furthest to the left here is our main controller. This is the brains of the operation. It's got a key switch right there, you can see. And you can turn that key switch to 3 different positions. There's a run, rem, and prog, which stands for program. Rem stands for remote, so we can remotely toggle between the two. And that's what it's in right now. We've removed the key, and we can toggle between run and program mode over there on our computer. A lot of controllers, this is a fairly new controller, and a lot of the newer controllers have both USB connectivity and Ethernet. Ethernet's fairly new to a controller. It used to be RS-232, so this is a fairly state-of-the-art controller that we have here. Now to the right of the controller, we have an Ethernet IP module. This is a communication module, and that's why it has this Ethernet cable coming, and you can see it has 2 ports actually. You can connect to 2 different networks. And this is added, not necessarily maybe required in this case, because we have an Ethernet port here that connects over to our switch. But before, a lot of the controllers didn't have that, and you would require this if you wanted to talk Ethernet or Ethernet IP. So it's a type of communication module. To the right of that, we have a DeviceNet communication module, which is more for connecting to individual devices that have DeviceNet communication protocol. And then over here, we just have 2 blank slots. These are just empty. There's nothing in here. They're just fillers, so we don't end up having stuff getting into our chassis and short-circuiting things and stuff like that. I don't think I can grab, oh, I guess I can. There, now you can kind of see back there into the chassis. You can see some of the pins and stuff where the modules connect. I'll just put that back down. It should snap back in, there we go. Now here we have a discrete input module, sometimes called digital input, just for on-off devices, open-close switches. discrete output. And if you look at the model numbers here, there's a lot of hints. 1756 means we're dealing with a Control-Logix PLC, which is Allen Bradley, here made by Allen Bradley. And 1756 is their Control-Logix line. That's how they identify it. Then there's an I, which stands for input. B, I wouldn't know off the top of my head what that stands for, but 16 indicates how many different devices we can connect to it. And then D means it has diagnostic capabilities, kind of an added feature. So when we look over here, you can see it's common again, 1756. O stands for output module, and it's got 16 as well, and the diagnostics capability. The /A, we're not going to worry about. It's nothing that we need for looking up wiring diagrams and stuff like that we're going to do here fairly soon. Firmware revisions are put here, but one thing to note, if you see a firmware stamped on a module like this, it may not be the up-to-date one. For instance, over here, our controller has firmware version 29 stamped on it, but I think they've been upgraded to 32 or something like that, and we can check that here once we get into the software. And then our last two are analog input modules. You can see I for input, F, and then 8. We have 8 of them, and then this H on the end here means it's got an added feature of HART communication. So this allows you to maybe calibrate a device or something like that remotely, is what HART does. It's a very similar idea to DeviceNet over there. It's for connecting out to devices. Over here we have an OF8, which is an analog output, and so the F is likely to indicate that it's an analog, some type of analog module that does like a 4 to 20 milliamp or a 0 to 5 volts or 0 to 10 volts. And the 8 on the end there indicates that we can have 8 devices. There's 8 channels for the analog cards. So we ran through the different modules. PLCs quite often are modular, not all, but the Control-Logix series is modular. The other added feature that Control-Logix has is these modules here are hot swappable, which means I could pull this out with power on the chassis and put in a new module without faulting anything. Some of the older PLCs, if you did that, it would fault the controller and it would stop executing logic and shut down your process. So that kind of goes over the main PLC hardware there. And up here, our power supply, we need this, 24 volts. All of our modules here use a 24 volt power supply. There's a circuit breaker right here, and then this flows down to right here. We've got a plus and a minus terminals, so we can connect power out to our end devices for anything that's a syncing device or a sourcing device, I guess. But we're going to talk a little bit more about that further on in the course. But today we're just going to go over kind of the wiring and how to connect a switch to this. So that kind of shows you where we get our power supply. It comes out down here, our 24 volts that we're going to need for our device circuits to connect to the PLC. Now down here, everything's kind of broken out. You can see there's these little banana plug jacks here that we can wire, and it's nice because we don't have screwed terminals like you would normally in the field. It's nice in the lab setting to quickly wire things up and not have to use a screwdriver all the time. It makes things a lot faster. And so how these are broken out, you can see some of the, I kind of want to talk about the color coding here. All of the yellow plugs here are plugs that do not have any power on them. They're like a dry contact. There's nothing there. There's no power supply connected to them currently, unless you connect one like I have with these wires here. There could be power flowing through them now. These ones over here that are red indicate that they will have, you don't have to connect to power. There's power, there will be power there. So there's power sitting there. Positive 24 volts, and this would be the common or the negative down here. And you can see here they're all labeled here. DC stands for discrete input, discrete output, analog input, analog output's written there. And so what has been done here is all of these in this column here are for our discrete input card, which was this guy right up here. So if I flip this open, you can see there's some wires that are connected to our screwed terminals. And if you look close, you can see there's numbers there on the terminals, 1, 2, 3, 4, one starting over here on the right. So basically it's just broken out down here. This is terminal 1, this is terminal 2, 3, 4, and so on. If we look back up here, the 1 was over right up in there. There's our 1, 2, 3, 4. And so it's just broken out all the way down. For all 3 of these modules, it's done that way. And if we ran out of room here, we just stopped. Like, I think that this one might not use all, like there's, what do we go down to, 35, looks like is the last one? Or maybe 36, actually it's probably 36, because I think, yeah, even's on the left. So 36 is probably over here covered by those wires. But if we go down here, we don't have 36 terminals. I think we only have, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. So we've only broken out the first 20 terminals because we don't need 16 inputs, right? We're only using the first 20, so approximately the first, I guess, 10 inputs is what we can wire up here. So that's how that's broken out. That's how all of these are broken out. And it makes it easy for us to wire them up and connect to them. And so what we have over here now is a power distribution. We have fuses, fuse clips. This is very commonly used in industry. And what we can do here is what we've done is that you can see I've ran the positive here. Let's see if you can follow this. The positive lead runs right up to the bottom here. And then I've basically jumpered. So this lead right here jumpers up to the one above it, and then the same thing. So I've jumpered, we've got 24 volts all on these 3 terminals here right now. That means with these fuses, if we open this, it breaks the circuit, and there's a little fuse in here. So then if for someone's working on a switch on the other end and they don't have the fuse out and they short circuit something, it's not going to shut off all of our inputs and outputs, and it won't be as disruptive to our process. So that's why these are each individually fused like that. I've seen PLCs wired out in the field where there's like a fuse per every 8 or every 4 inputs. The only problem with that is if you short circuit one device, if you're working on it, checking it out, troubleshooting it, it could knock out all those other devices and they're not functioning properly. So maybe a little more expensive here, but it does have its benefits to not being as disruptive if we short circuit something. So that's what's really nice about our lab here. What I really like about our PLC lab here at Ritter College is the fact that we can actually wire up all these devices. I've seen a lot of trainers out there that are pre-wired. And when you get out in the field, the wiring is a very important thing to be familiar with and to be able to troubleshoot it. So I've only wired up one device here. You can see that this now goes down. Just follow my hand here. It goes down and it's connected to our trainer board down here. This trainer board has 4 red LEDs and 4 green LEDs, and then it has 4 momentary switches. They just stay in the position that you leave them in, and then it has 4 normally closed push buttons. So that means if you push it, it opens up, and you release it, it goes back to its normal state of closed. And then we have 8 normally opens on the bottom here. So the other nice thing about our trainer board here, I don't have one handy, but what we've done is we put dry erase board here so I can write and label these switches for our labs here. So an in-person lab here at the college, you'd be able to label all these, and it's a good exercise to get into the fact of good practice to get into labeling all of your switches. So the way that this is done now, you can see they all have a number tag to them. So 1 over here, 2, 3, 4, and it goes all the way up to 24. And what that's referring to is the set of contacts, dry contacts, because they're yellow, that means there's no power here. So if we wanted to connect to our LED there, number 1, we'd put our contacts across these 2, or our wires across these 2 contacts right here, connection points. And so the one that we are wired to, though, you can see right here is number 17 right now. So that means we've ran power here up to our top fuse we're using, coming out of our top fuse, and then down, and it's connecting to switch 17 here on our little trainer board. So if I push this button, it would close. When I release, it would open because it's a normally open. That's what the NO stands for, and the NC stands for is the normal state of that momentary push button. Then after it comes out of here, it goes in and out of 17, and now we're going up and over to our discrete input card. It's a switch So it's likely going to be, it should be connected to a discrete input. It's not a light. If it was a light, it should be connected over here to our discrete outputs. Otherwise, it's not going to serve its purpose. But it goes into this terminal, which is terminal 1, we know, the top one, top right, and comes out on terminal 2 and back over here to our power supply and completing the loop. So we've got a fuse in series, a power supply in series, and our switch in series. And what I wanted to do now is just to sneak over to the computer here, and I'm going to pull up the manual for that particular module. And I've got it here. What I'll do actually, this is the 1756 Control Logics I/O specifications, and it's got a whole whack of different modules here, but the one that we're after is the 1756 IB16D module. And I just searched the document, and I just went down until I found the wiring diagram here. And so if we look at the wiring diagram for the module here, they've got our DC power supply right there, and that's our 24 volts that we are using. The positive goes out, and then it goes to our switches, you can see right there. And those switches then come into our right side. So we've got the power supply, ours went through a fuse, and then it went up to our momentary switch, and then it went into number 1 up here, which is in 0, which means it's bit 0 on our card, because you can see it has 0 to 15. It has a total of 16 if you include 0. 0 to 15. It has 16 inputs on our card. And then after, over here, ground 0, all 4 of these terminals are actually common. So any one of those 4, it could be the top one, it could be 2, 4, 6, or 8, runs back, out, and down to the negative side of our power supply, is what that's showing. So they have 3 devices wired up there. We only have the 1. You may be wondering what this little leakage resistor is for. And what you can do is you can install a little resistor on there. And what that'll do is it's used to detect an open loop. So if the fuse is blowing, then there would be nothing flowing through this leakage resistor, and the card would pick up, okay, there's no current flow, there must be a fault, there must be open. So this here is going to be likely a fairly high resistance, so it allows a little bit of a current to leak through. That's why it's called a leakage resistor. Let's just see if I can just scroll down. I just want to take a peek if they say. I don't see it anywhere, just by a quick glance on the leakage resistor. But anyways, we'd have to look somewhere else in the manual for that leakage resistor. But if that was installed in parallel there with the switch, then it would be used for the diagnostics. That's why it has the D there, using for diagnosing to see if the circuit's open, if there's a loose wire or something like that. And that's what this does, is it completes that circuit to allow that small current that this module can then detect. But we have it wired up correctly. We've followed this diagram. Now what I can do to confirm that is up here on the module, you can see there's an ST light. I think it stands for status. And you can see if I look really close, they're kind of all grayed out right now, but the 0, oh, actually it's in red there. But yeah, the 0 right here. And I think that it's faulted right now, and that's because we don't have the leakage resistor in there. This would likely not be red right now if the leakage resistor was in there, allowing a small amount of current to pass. But right now the status is 0, it's grayed out. And what I'm gonna do is I'll just leave you guys up here, and I'm gonna push that push button, close the switch, and you can see there it turns orange. That means that it's detecting that the switch is closed. I let go, it opens up, and it shuts off. And what I was doing, I was just pushing this switch right here. It was opening and closing that. So there, we've gone through a quick little setup on the wiring. I referred to the manual over here on the computer. And now, the last bit here of the demonstration, we're going to be going over the software that's used to connect to the PLC. Okay, I'm going to bring you guys over to the computer here now. If we have a look here, we've got Studio 5000 open. I'll just maybe close this on our desktop. It's this icon right here. So for any of the labs in the future, if we are remoting in, you'll be able to find it. It's just right here on the top. So just double click on that. And we want to make a new project, so we'll just click on New Project here. And it's asking us, first thing it asks us is saying, okay, what kind of controller are you using? You need to know what kind of controller that you're using. And it's nice that it's already selected. We're using the Control Logic series. You can see there's some others, like the Compact Logics, Guard Logics. Let's see if they have any more down below. emulator. So if we want to just simulate the hardware, we have that installed in the computers as well. And there's some safety controllers as well. But our 1756L81E, so we need to know that. So that's what we checked over here. It was shown, I'd stamped it right on the outside of the controllers, so it was there for us. But if we didn't know what it was, then we would have to pull the controller out and look at the catalog number or part number on the side. So we've selected that, and now we need to give it a name. And so we'll just call it Lab 1. And click Next. And the revision number we can leave as is. So like I said before, it's been upgraded to revision 32. They do have a sticker for 29 on them. Our chassis, we need to make sure we have the right size chassis. You can see that there's a 4, 7, 10, 13, 17 that ControlLogic, or that Alan Bradley makes for the ControlLogic series. And so to do that, we would need to count the number. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 slots in our chassis. So we need to make sure that we select 10. And it's wanting to know what slot the controller is in. So we can select from 0 to 9. And it was in the furthest left. This is where slot 0 starts, is right here. The power supply does not have a slot number. So it's in 0. That's kind of the default. No protection. We're not going to lock this controller or anything like that. So we can leave all this unchecked and then click Finish. So now it should start up a project for us. All right, so our project, we've got a blank project here sitting in front of us for a 1756 L81E controller. And what we're gonna do here first is we're gonna make sure that we can communicate with it. So we're gonna go to the communications up here, and we're gonna go to Who Active. And what we have here is our Ethernet driver on the workstation here. This is the workstation up here that we're on, which is basically the computer. And we're using an Ethernet port to connect out, and then it's going out to our switch. And from our switch, it can see that there's a 1756 L81E Logix controller here, a panel view plus, which I pointed out earlier. And then it's also picking up that other communication card in our chassis, the EN3TR, which is this guy right here, EN3TR right here. So it's seeing that guy as well. And those are all of the devices that have Ethernet cables connected to them. And so I should be able to actually disconnect, we'll do this one. I'll disconnect this one from the network, the Ethernet IP module, and we'll just do should be able to, oh, there we go, yep. And so there you can see it lost it, can't see it anymore, so it's got that red X on it. So that would indicate that we can't communicate with the device if, in this case, the cable's unplugged. Sometimes it can be other things like settings and stuff like that. So I'll connect that back up, and then we should be able to see here that it should come back for us. But for now, we're gonna click on our controller here. We're gonna drill down. There you can see our backplane appearing. Oh yeah, so there's the backplane right there. You can see showing up now. We've basically drilled out through the Ethernet port on the controller. Then it found our backplane, and then now it's showing us all of our modules that are on the chassis right there. We can also do that same thing through our card down here as well. I'll just give this a refresh and it should find it. There, now you can see the X is gone down here. But we should be able to drill down, and technically there you can see the backplane, and there we can see all of the same cards here. So it doesn't really matter which card that we use. We're gonna use the controller since it does have that Ethernet port on it, but we can find all the cards the same way. So we went into our communications up here, and we've gone into Who Active. What we want to do is we want to tell the project where to find the controller. And so we need to select our 1756 L81E controller right here. We select that, and then now down here we just click this button, Set Project Path. So now whenever we open up our project here, it's going to know where to find our controller so we can send information to it, upload or download. If we want to download our project or any of our programming or anything like that to the controller, the project now knows the path, and that's why we set that there. And so what we'll actually go ahead and do right now is we'll close, actually no, what we'll do is we'll download this project, and it should overwrite anything that was in there. It's giving us a warning. It's saying, hey, if you have any machinery being ran by this PLC right now or anything like that, doing a download could create a hazardous situation. It could shut things off, turn things on unexpectedly. So we're gonna go download, and it's gonna send our blank project out to the PLC. Just give it a moment. There, it's saying done downloading. Change controller back to remote run. So it's wondering if you want to put it into remote run. Yes or no, we'll just leave, we'll go yes. And since our key switch on our controller is in RAM right now, we can toggle between run and program mode. We should be able to do it from here. Oh, right here. Right there. So you can see I can go and I can put it into program mode, and it's going to prompt us and say, hey, are you sure you want to? I'll just say yes. And now you can see that it's in REM program mode right now. So that means it's not executing any logic if there was any, but we'll switch it back to run mode. Click yes. Okay. So the next thing that I wanted to do is I wanted to add at least our discrete input modules to this project. And the way that we do that is there's two ways actually. Since we're online right now, we're connected. You can see we've got green lights up here. We can add them by just discovering them. So what the software will do is it'll go and discover them and then add them to the project here for us. Or we could manually add them. The problem with manually adding them, if we're offline, so if we weren't connected right now and we were doing this remotely, we weren't connected to the PLC at all, we were in an office somewhere writing a program, building a project, and we're going to download it later, what we would need to know is all of these firmware versions here. We need to know the correct firmware versions. If we don't know the correct firmware versions, then you won't, when you download your project, you'll have errors. It'll throw errors because it won't be using the right software to communicate to the modules. So what we want to do here is we're going to do it the easy way. We're going to right click and go discover modules. Since we're already here, we're connected to the PLC, and there it gives us all of our modules right here that we have, and it gives all of the revision numbers for us. It found them. It talked to the modules and asked them what the revision numbers were, so we don't have to figure out what they are and do it ourselves like we would with an offline project. So we want these two. These are this is our discrete input module, IB16D, and this is our discrete output module, OB16D. So we want to create those. If we click create, then we can leave our name blank because I usually just leave it blank, but you can call it discrete input or something like that, or if it was had a certain location on a facility, you might want to give it that name as well. Or it's connecting devices from a certain process, you might want to give it that name as well. The slot number, this is another thing that you would need to know if you're doing it offline. You need to know what slot the module is going to be in, but since we're adding it, it gave us slot 5 already, so we'll click OK. And it's just giving us, we're doing an online module creation, so it's just giving us a heads up on that, that it could affect the running system. So we'll click yes, because we don't have anything connected to our PLC except for one switch right now. And we also need to create our discrete output modules. So it's on slot 6, it picked that up for us, it knows the revision number, and we'll click OK. And click yes to our prompt here again. So there, now over here in our I/O configuration folder, you can see those two cards have been added along with our controller right there. So those are the only 3 modules that I wanted to work with right now, so that's all I'm going to bother with adding right now. So we're going to go ahead and click close on Discover Modules here. And the next thing that I wanted to do is I wanted to write just a small program and test the program here and use our switch. So what I'm going to do is drill into main program here. So in our tasks folder, if we drill down, main program, and its default, the default program here is always going to be a ladder diagram. You can see right here, there's a little ladder on the icon. So it's ladder logic. We may not have covered much of ladder logic yet in this lab, but we're gonna do some very simple stuff with this. So if I double click on here, it's gonna open up what looks like kind of like a ladder, I guess, here. And this is red right now because there's nothing there. So we need to add some instructions. So we're going to do some simple logic. I'm going to add 2 examine on instructions here and a output energize instruction. So there we've got those added. You can see that. The next thing is we need to connect some devices here to our logic, so then it will function properly. And so what I want to do here is go into our controller tags. And now that we've added our 2 modules, we've got some inputs here and some outputs here. And so we should have covered the addressing here by now for our PLC, but if we haven't, just a quick little overview. Local here in our address means that it's a local module, so that means it's on the local chassis here. If it was on a different chassis, we might be talking out to it through this Ethernet cable. And so it might have an IP address or the name of this module in place of local there. 5 is the slot number. I stands for input, and then data indicates that it's discrete. And then you can see data.0 all the way up to, it should go up to, this might just need to be made a little bigger. There we go. It should go up to at least 15. Looks like it goes past, but we would only be able to use up to 15 there. Probably goes past because it looks like it's using a double integer to store the data, which is 32 bits. So it probably goes up to 31, right down there. Yeah, but we're only using the first 16 bits. All right, so now what we're gonna do is we're gonna work with our main routine here. We're gonna do a little bit of programming and use some of our use our inputs here, inputs and outputs that we added to our project. We're gonna connect some more to the cards. So if we open up main routine here, this is a ladder diagram program. You can see there's a little ladder there, and that's kind of the default is to start with a ladder. So there's some other programming languages that we'll work with in this course, but the first one we're going to be working with is ladder diagrams. So you're going to see a little bit of that today. We haven't talked probably a whole lot about it just yet, but we're still online, and what I want to do is I'm going to go offline. So if we go communications, go offline, and what this does is it makes it a lot easier to do our programming. If we do it online, you have to accept edits, and there's just quite a bit more steps to it, and it slows things down. So if we're not programming on a live process that's actually running right now, I just recommend going offline. It speeds things up. So what I want to do is go over to our controller tags, and I think I'd already created some tags here, but we'll just do one of these again here. Oops, just delete this tag. Let's put that back. I should be able to delete this. Delete all 3 of these. So I want to create 2 tags. I want to create some alias tags, because if we look here, these addresses are kind of the base tags, the direct addresses. There's just, it'd be nice to label it like a a level switch or something like that, so we know the function of the device. To start things off, we're just going to use A for our first input, and we got to select it, local 5, I for input, data 0, and we'll do B, and that'll be our second input on bit 1, and then Z will be on output. It'll be one of our outputs. We'll go with Z is going to be at the end of the alphabet, so we'll start our outputs there. So there, now we have 3 alias tags that we created here. And we're gonna go back over to our main routine, and we're gonna drop in a new rung. And we're gonna add some instructions here. We're gonna put 2 examine on instructions in, and we're gonna put a output energize over here at the end. You can see the outputs show up on the far right and the inputs on the left. And sometimes you have to toggle between controller tags and back to the main routine. So I'm just gonna do that to save us time, because sometimes you create your tags and it's not until you go back and forth once that it actually can recognize them in here. But if I click the Shift key and A, press Enter, you can see there it threw up the base tag or the direct address there. If we wouldn't have, if it would have been, if I put in V, we haven't created anything for V, so it's nothing. You can see it doesn't really recognize it. So it would likely give us an error when we try to download the project. B, and then over here our output is going to be Z. And you can see that all of them have that base tag or direct address that we linked to those letters in our controller tags. So now that we have that done, what I want to do is I'm going to go online, I'm going to download this, and we're going to click download. It's giving us a danger warning again. We're going to download our project, and this here is bit 0 on our input card, which is the one that we have our switch wired to right now. We're going to see if that instruction changes when we open or close our switch here. So what I'll do, it looks like everything's downloaded, and we've got green lights here indicating that we're online right now, and we're not in program mode, we're in run mode. And just hang on a second. Are we? Oh no, we're not in program mode, or sorry, run mode. We're in REM program. The reason I knew that we weren't in run mode, we weren't executing logic, is because the ladder rungs, or I guess the ladder rung here wasn't green, and that needs to be green. So I'll just change this back to run mode. Click yes. So now we're viewing, you can see that this is green, this is lit up. And now when I push 17, I'm going to push this 17 push button that we wired in here. When I push that, you can see there the instruction became true. It turned green, indicating that it's true. So if this instruction and this instruction become true, then it will energize output Z over there. So what I'm going to do now is I'm going to complete the wiring here, complete the rest of the wiring, and then we'll test this and confirm that it works. I've got 3 devices wired to the PLC. I've got our, I've labeled it now A, our normally open push button here, and then B over here, 13, and then Z, which is one of our lights here. So if we look, quite a bit more wiring now shown here. I did modify one thing here. What I did was we had our power to our 3 switches, wired up here. I moved it up to here and just jumpered. We were only running power 24 volts to these 2 fuses on this side. For the output, which is over here, what I did is we ran power. You can see power, the 24 volts. We ran it right up here directly. And the reason being is if we look, these first 1, 2, 3, I believe 4 here are, if we look over at our, I'm going to bring up the manual wiring diagram here. For the 1756, this is the OB16, the output module. You can see the positive connects up here, and all 4 of these or more. There's more than 4. 1, 2, 3, 4, 6, 7. All 7 of these are common with each other because they all have the same label, DC-0. They're all common. So that means if I wanted to isolate one of these devices over here, my fuse wouldn't, if I opened the fuse, if I went directly to that fuse like we were before, it would shut power off to all of these. So I ran the power up here first, and now the fuse is going to be in between here and the device. So just to show that now, power goes down and it goes up here to these common, these first 7 terminals are common. And then the card is going to energize once the card up top here, once it energizes and allows current to flow out here, it's going to flow out down and to our bottom fuse clip right here. And then so if this clip is closed and the fuse is good, then it's going to come out on the black lead here, and it's going to go down to our number 1 right here, which is our light here. And these are diodes in here, so they're polarity sensitive. So that means we need to go in here and then out here to our negative of our power supply. So that's what we should see happening here, is this flows out and comes back to the negative here on our power supply. So if the program isn't energizing the output right now, it'll be open circuit between these two. But then when the program tells it to, it'll close and it'll conduct to the fuse and down to our light, and it should turn on. So let's test this out. Let's test out this program here. If we have a look back at Studio 5000 right now, you can see instruction B is true right now. We should know why by looking at the type of switch that it's connected to. It's true right now, and A is not. These are both the same instruction. They're both examine-ons, but you can see this one's true and this one's not. And over here, our output's not true right now. So what I'm gonna do is I'm gonna go and push A, close it because it's normally open. We're gonna close it. They're both true now. I'm pushing it. And Z is now true, it's on. So what that means is up here on our card, we should see our bit 0 on the output card there. It's energized. That means it's now conducting through the card. And if we look down here, Z, our light is on our trainer board. So it's functioning, it's energizing the output right there. And if I let go of bit 0 here, you can see that 1 is still true because of the switch it's connected to. And then over here, this went out because the output's not being energized. So these status lights are actually quite handy when it comes to troubleshooting a PLC if you have any issues, right? If the switch is supposed to be closed right now or open right now, you can look here and see if the PLC is getting that information. And you can also see here if it's supposed to be outputting, if the program says it's supposed to be outputting and it's not right now, you can use that to troubleshoot as well. So those status lights are quite handy. So hopefully that gave you kind of a good grasp on the wiring. It's important to be familiar and know where to find that manual so you can wire this thing up, wire devices to it. And it kind of, we did some communications here with the PLC. We downloaded a project, we wrote a small program, verified that it's working. And so there's gonna be some questions here to answer now. Since this is an online lab, it was a demonstration, there's gonna be some questions to answer on what we did here now today. So one last thing I did want to mention actually before you go and answer your questions is to save your project here that you just did today. So if there's any lab that you want to save in this course, you can do that by going File and then Save As, and you're going to want to put it not on the computer, because these computers are set up to erase everything when they are rebooted. So you'll want to go to, sorry, I kind of went fast there. When you go to Save As, click this PC right here, and then there should be, anyone that logs onto these computers should get some sort of a network drive here. Just save it on your network drive, and then you'll be able to access it at a later date. Because if you do not, and the computer does get rebooted, it will clear everything. And we've set it up that way for troubleshooting, because if settings get changed and stuff like that, it kind of is a good starting point whenever you just have to restart the computer and it fixes things. So make sure you save your project if you do want a copy of it, and that's how you do it.